The Mississippi River.
The Mississippi River.
Mississippi River.
The Mississippi River, this is also incredible, has hit historic low levels due to the current drought.
On October 17, 2024, satellites orbiting 440 miles above Earth captured something that should not have been possible. Images from NASA's Terra satellite showed massive sandbars emerging from sections of the Mississippi River, areas that had been underwater for more than a century. In some locations, the river was less than 3 feet deep. This wasn't a slow geological process. This wasn't a drought. Rainfall across the basin in 2023 was exactly average, yet barges carrying nearly 60% of America's grain exports were stranded, sitting motionless on exposed sandbanks. A river that moves over $700 billion in goods every year had shrunk to something barely navigable. The question is no longer if the Mississippi is drying. The question is, where is the water going? The impossible deficit. Engineers inside the lower Mississippi River Division of the United States Army Corps of Engineers discovered something even more disturbing. Water entering the river at Cairo, Illinois, was not arriving in Baton Rouge, Louisiana. It wasn't delayed. It wasn't slowed. It was disappearing. Between milepost 953 and milepost 233, nearly 200 billion gallons per day were going missing. That's enough water to fill Lake Tahoe every 11 days. For hydrologists, this violated one of the most fundamental scientific laws, conservation of mass. Water doesn't simply vanish. The Mississippi-Missouri River system drains 41% of the continental United States, from Montana to Pennsylvania, through a network of 271 monitoring stations operated by the United States Geological Survey. For nearly a century, the math always balanced. Water in minus evaporation minus withdrawals equals water out, until it didn't, when the numbers stopped making sense. At Tarbert Landing, Louisiana, flow rates typically measure between 400,000 and 600,000 cubic feet per second, roughly an Olympic swimming pool of water passing every 3 seconds. That flow is the backbone of barge contracts, water rights, flood insurance, and billion-dollar agricultural systems. Then, in late 2023, Dr. Amanda Winters of the USGS Baton Rouge Water Science Center noticed something that should have triggered an alarm decades earlier. The river was losing 53,000 cubic feet per second over a 600-mile stretch. For perspective, that's nearly the total flow of the Colorado River. She recalibrated instruments. She repeated measurements. She verified data. By December 2023, the loss had grown to 89,000 cubic feet per second. By March 2024, 143,000 cubic feet per second. The Mississippi was hemorrhaging water. Emergency review. In April 2024, the Army Corps convened an emergency technical board of 37 leading engineers and climatologists. Their conclusion was chilling. Measured losses far exceeded natural variability by a factor of 6.7 to 1. Evaporation couldn't explain it. Agricultural withdrawals didn't explain it. Climate models didn't explain it. So what could? Theory 1. Farmers are taking too much. The Mississippi Basin supports $60 billion in agricultural output annually. Arkansas rice, Louisiana sugarcane, Midwest corn and soybeans. USGS data from 14,000 agricultural wells showed groundwater usage of 8.1 billion gallons per day. That sounds massive, but it was nowhere near enough to account for 200 billion gallons disappearing daily. Even reduced cotton acreage in 2023 meant withdrawals were actually lower than previous years. Agriculture alone wasn't the culprit. Theory 2. Evaporation spike. Scientists turned to satellite thermal imaging systems like EcoStress to measure evapotranspiration. Results? Evaporation was up 2.3% above the 30-year average. That increase would account for roughly 4,000 cubic feet per second of additional loss, not 143,000. Evaporation wasn't swallowing the river. Theory 3. A giant underground cavern. Could water be draining into hidden underground cavities? A seismic study conducted by Tulane University and the University of Memphis deployed 127 sensors across the riverbanks. They searched for massive karst formations, limestone voids that could act like giant drains. They found none. Bedrock structures were unchanged from previous surveys in 1997 and 2012, but they did discover something strange. The sponge effect. Sediments beneath the riverbed showed dramatically increased porosity. Normally, sand and gravel deposits under the Mississippi measure around 30% void space. In 2024, they measured up to 47%. It was as if the riverbed had turned into a sponge. More void space means more water storage capacity, but storage alone doesn't remove water, unless something is pulling that water away as fast as it fills. Theory 4. The river is feeding its own aquifer. This is where the puzzle pieces finally aligned. The Memphis sand aquifer and the Mississippi River Valley alluvial aquifer supply drinking water to 8 million people. Since the 1960s, municipal and agricultural pumping has steadily lowered groundwater levels. By 2024, water tables averaged 23 feet lower than 1990 levels. When groundwater drops, it creates suction, a hydraulic gradient. Hydrologists call this induced recharge. The river begins feeding the aquifer, but in 2024, that recharge accelerated to catastrophic levels. The Mississippi wasn't drying because of drought. It was bleeding into its own groundwater system, a hydrological trap. For 100 years, we built levees, we built dams, we drilled wells, we straightened channels. Each project made sense individually. Together, they rewrote the river's natural balance. Now the riverbed sediments, loosened and porous, funnel water downward into aquifers depleted by decades of pumping. The system became a trap. Ecological collapse. By mid-2024, dissolved oxygen levels dropped dangerously low in Louisiana's lower basin. Commercial landings of channel catfish fell 64%. Paddlefish larvae failed to survive due to insufficient flow velocity. Riparian forests that depend on annual flood pulses stopped regenerating. Invasive species took over. The ecological consequences were immediate. Economic shockwaves. The Mississippi carries 500 million tons of freight annually. Every foot of reduced depth decreases cargo capacity dramatically. By August 2024, shipping loads were cut 35%. Grain shipping costs surged 71%. Cargo volume dropped 41% at the port of South Louisiana, the Western Hemisphere's largest tonnage port. 4 barge companies declared bankruptcy. Farmers absorbed losses. Consumers paid higher food prices. Then came saltwater intrusion near the Gulf. Communities like Belchasse lost potable water access. 80,000 people affected. The solution that backfired. In September 2024, the Army Corps launched a $2.3 billion recovery initiative. Reduce groundwater pumping, restore wetlands, modify dam releases. On paper, it would restore 40,000 cubic feet per second within 18 months, but unintended consequences emerged. Farmers switched to direct river withdrawals. 2,700 new surface intake permits were issued. Wetlands meant to store water instead accelerated recharge into the aquifer. More intervention created more leakage pathways. By February 2025, river discharge hit its lowest recorded level. The Corps quietly changed terminology from restoration to adaptive management, a subtle but telling shift. Storage deadlock. Engineers now describe the situation as storage deadlock. Water exists, but trapped underground in zones unreachable by wells. The river continues feeding the aquifer faster than the aquifer can redistribute it. The system contains water. It just can't use it. The bigger question. The Mississippi supports 10 million people. Over $200 billion in annual economic activity depends on it. More than 400 species rely on specific flow regimes. For a century, engineers believed the river could be managed like machinery. Now we're discovering rivers operate on geological time, not political time. The satellites continue to collect data. The gauges continue to record deficits. And beneath the sand grains laid down by ancient glaciers, billions of gallons settle into storage that may not be released for centuries. The Mississippi isn't drying because we failed to manage it. It's drying because we succeeded in reshaping it too well. There are no simple answers, only a slow, measurable retreat, and a river rewriting the rules we thought we understood. If you found this investigation important, share your thoughts below. Do you believe this crisis can be reversed, or has the Mississippi reached a new equilibrium? Like, share, and subscribe for more deep dive environmental investigations. The water is still disappearing, and we are still watching.